Hello, you're welcome to our channel Skills Learning Network. If you are the student of advanced level, you are welcome. If you are the teacher of advanced level, you teach advanced, so you're welcome to our lesson for today. This is a new lesson, Chemistry Practicals, advanced level. And our topic, we are going to look how to solve, how to perform experiment which involve partition experiment, distribution law, partition coefficient or distribution coefficient, KD. So be together with me. My name is Mr. Maguru, expert in physics, chemistry and biology practicals. Welcome to learn with me from the first up to the end of this lesson, and we are going to the lab to perform a real experiment. Let's proceed. So advanced level, form 5, this form 5 and form 6, and you look, that is a partition. You see the funnel, there is two layers. What we mean when we use the term partition in our lesson for today. Chemistry practical, partition coefficient. What is partition coefficient? Partition coefficient is the concentration ratio of a chemical between two media at equilibrium. As you see the first image there, you see there is a separation of two liquids. So we use partition. That is a concept of partition coefficient, the concentration ratio of a chemical between two media at equilibrium. There is sometimes when you mix the solvent, there is one distributed to another. So we are going to determine the concentration ratio of that solvent. In addition to that, we have distribution law, which states that the relation of a concentration of a solute X distributed between two immiscible solvent or miscible liquid A and B is kept constant. That is distribution law. We proceed by looking that you see that is a separating funnel. There is liquid X, liquid Y. So there is the constant distribution coefficient. Distribution law we can proceed as if the solute the solute gets distributed between two layers of immiscible solvent in such a way that the ratio of the concentration in each solvent become equal to the ratio of its solubility. That is KD, or distribution constant. You see that is a formula. Concentration 1 over concentration 2 is equal to constant, where concentration 1 is the molar equilibrium concentration, the constant is the distribution, or which the K is constant coefficient, distribution coefficient. That when we say partition, we deal with two solvent liquids which cannot be mixed together totally. There is one is going to distribute itself within another solution or solvent. That is distribution concept, and that is our lesson for today. We have apparatus, we have a solute used and a solvent. We look at the solute used. For these experiments, we can use ammonia solution, we can use succinic acid or butanoic acid, iodine solution, acetic acid gaseous or ethanoic acid. Those are solute are used in our experiment of partition. We look at the organic solvent. The organic solvent which can be used, there is diethyl ether, there is chloroform, there is carbon tetrachloride, There is isobutyl alcohol. Those are some of the solvent can be used in different experiment form. That is but apparatus, the most apparatus used, we have a separating funnel, we have a measuring cylinder, we have a burette, and we have little stand. In addition, you can have a pipette. Those are apparatus. And another, there is a titration flask or conical flask to perform titration, because partition experiment involves the titration procedure. That's why you find the concentration. So now we start with the experiment number 1, partition experiment number 1. Be together to understand more. You are provided with the following solution. We have W1, which is 0.1 mole or molality sodium hydroxide. W2, unknown concentration of succinic acid. Number 3, we have a phenolphthalein indicator, which is a POP. The function of this is to identify the color change at the end of the reaction. And then number 4, we have diethyl ether. This is organic solvent. And the diethyl ether we are going to mix with the succinic acid to make distribution. The theory, what he said, at a constant temperature, succinic acid dissolves in both water and the diethyl ether while maintaining a constant ratio of a concentration in that solvent. That is the theory for this experiment. We are going to use diethyl ether and the succinic acid to make distribution. Procedure A. Pipette 25 of W2, which is succinic acid, into a conical flask. Add to it drops of W3 POP. Put W1 into the burette, which W1 is sodium hydroxide, 0.1 molality. Procedure number 3, titrate very carefully solution W2, which is succinic acid, against W1 sodium hydroxide till there is a color change by using your indicator. Titrate against one color change. Record the volume used as well as the room temperature. The room temperature here is 20 for now. Even if we are going to measure with the thermometer, we observe that is 20. So for procedure number 1 or procedure A, let's go to the laboratory to see how this can be performed and what the results we are going to get. Let's go direct to experiment. You will see and you understand. Okay, welcome to our lesson. Today, now we are going to show you how to perform this titration for the first procedure and the second procedure, or procedure A, procedure B. So let's go direct to our to find the concentration. Our experiment to find the concentration. The first procedure, or procedure A, we fill a sodium hydroxide or solution W1. This is W1. We fill make sure you fill above 0. You fill above 0 in order to fill this tip. We're going to fill this, and then that is filled. So now our burette is filled. Remember, in first procedure or in procedure A, you have to perform normal titration. Means this is sodium hydroxide within a burette. We are going to titrate with the succinic acid, which is W2. before mixing with the organic solvent, which is diethyl ether or W4. So after filling this one, we are going to measure with the pipette. You can use a pipette or you can use measuring cylinder. So to save the time, we use measuring cylinder to measure volume of W2. I measure 25 W2. Then after, I'm going to put in a conical flask. In a conical flask. So this is succinic acid or W2. We are going to find the concentration of this one. Then we have the methyl indicator W3. I put 2 or 3 drops of indicator, drop 1, drop 2, drop 3. Then we are going to titrate sodium hydroxide against the succinic acid, which W2. Then first you have to raise the ignition volume 1.3. Then we are going to titrate. You see pressure. You see the color change. That will be ending point for our reaction. Yes, it is a color change which is pink. You will see this. It is pink color. This is pink color. So from colorless to pink. Then we are going to find the initial, the final volume. Remember our initial was our initial was 1.3, but our volume now is 26.3. So the final volume or the initial volume, the volume used, we say that is 25. So that is the first procedure. For the second procedure we are going to perform, we are going to mix with succinic acid and organic solvent. We have to make a solution of this, then we are going to put it.
I think you have seen the results. You have seen that the results, our results usually the volume of pipette usually was 25. The volume of W after titration is 25. And the room temperature, I have said that is 20 Celsius degree. That is our results. And then procedure number B. Measure 100 of W4, which is succinic acid, using measuring cylinder, and place it into separating funnel. Number 2, you add W2, which is succinic acid, by measuring cylinder. You put in the same separating funnel to mix with succinic acid.
or to mix with the diethyl ether, and you shake well for a few minutes, and you allow to stand, and you have to run off the layer using metal cylinder. You measure 25 of the aqueous layer lowered, and we are going to titrate with the W1 by using indicator. So procedure B, also we go to laboratory to see how to perform this experiment.
For the second procedure, we have to mix W1, W2 with the organic solvent, which is diethyl ether. So according to the question, we have to measure 100, but according to this, for us in the procedure we are going to use 50. Or if it will be enough, 100, we are going to use 100. It means we have to measure. We are going to use this separation funnel. We measure this one, W4. This is the organic layer. Yes, this is the 100. Then we are going to put in this in separating funnel. Remember, we are in the second procedure. Then we are going to put 100 of W2. Then we are going to see how the partition can be formed. Then we are going to shake. Before shaking, you see there is a layer. There is layers, 2 layers. There is a junction of this. So we have to make distribution of succinic acid with organic layer. We are going to shake. Make sure you shake well. In order to make distribution of your solution, to distribute, then you leave it. You will see there is a layer. So another procedure you have to remove. To lower this one, you have to remove in order to make titration with another for the second one. To get the concentration which distributed to this. This is succinic acid aqueous layer. It's going to have been distributed to this. So we have to, in order to have a good pressure, you have to remove this one. Then remove. You can remove. This can be enough to another experiment. Then you put aside. Then this is the lower layer from separation funnel. So we have to use this one, titrate again with this sodium hydroxide to identify the concentration distributed into organic layer. This we proceed. We measure also 25. We put a conical flask. We are going to add Q1. You can set to 0. Then we'll see what's the end point. Then we add 2 drops of W3. One, two, three. Then we are going to make titration. Our initial zero. Find the ending point. We will see the ending point. Okay, there is a color change. You see, this is not colors. We have a color change. Our volume is 22. Our volume is 22. 5. So, for the first was 25, and for the second procedure was 22. So, there is amount of concentration reduced by organic solvent. So there's the distribution of succinic acid to organic layer that's caused to disturb the volume from the initial to this 22, or from 25 to 22 volume. So that is how we can perform experiment on partition. We have a form of questions. So this is the first experiment. We will see another experiment, number 1, number 2, even if number 3, and then number 4. I think you have seen how to perform titration with the partition experiment through distribution laws, organic solvent with the in water. I think enough. Let's go to calculations.
I think we have seen the experiment performed. Let's proceed with to remember the results. The results was in aqueous layer. After lowering the aqueous layer, the lower layer, we measured 25. We put in a conical flask and then we performed titration. The result was 22. So there is a concentration reduced. So that's why the tighter volume used to neutralize 25 of sodium hydroxide was 22. It means there is a reduction of the concentration in acid because there is a distribution of the same amount within diethyl ether. That is the results of our experiment. Let's proceed with the questions. The first question, write down a balanced chemical equation representing the reaction taking place in procedure A3. That's a balanced chemical equation between succinic acid and the sodium hydroxide. Another question: calculate initial concentration of W2 in water. That is the concentration for the first procedure, for procedure A. You have to find the molarity of succinic acid. Number 2, final concentration W in aqueous layer. That is the concentration after mixing with the succinic acid and the diethyl ether. Deduce the concentration of W2 in organic. It means by using initial and the final, we are going to take initial minus final to get the organic, which have been the amount of concentration distributed to succinic, to diethyl ether. With the last question, you have to calculate the partition coefficient or distribution constant between aqueous layer and the diethyl ether. The concentration in aqueous and the concentration distributed to organic layer. Those are questions you have to understand one by one, to know how to solve, to make clarification on your mind, and then you are going to proceed with the answers. Let's proceed with the how these questions have been solved. We can understand this. When a solution of succinic acid is shaken well with the diethyl ether, the succinic acid will distributed itself between two systems of solvent. So for this question, we are supposed to find the unknown concentration of succinic acid present in initial concentration in water by titrating succinic acid and the standard sodium hydroxide. That is the note you have to understand. Okay, the results for procedure A was this one: 25. The room temperature was 20. I think you have seen there before. And then we proceed with the answer. The result for procedure B, the lower layer measured was 25. The final volume used of sodium hydroxide was 22. We start with the answer for question. The first question, balanced chemical equation. Balanced chemical equation was, it means succinic acid, it has two carboxylic acid. So that is succinic acid, aqueous solution, react with the sodium hydroxide, and the product is succinic. That is our product, and the end product is plus water or liquid. This is the liquid, sorry, not aqueous. This is the liquid, not aqueous. Water is liquid. That is our balanced equation. The molar ratio, number of acid is 1, number of base is 2 mole. I think we are together in our partition experiment number 1. This equation performed form 5 and form 6. This is advanced level. After balanced equation, the first equation calculated the initial concentration of W in water. That is the concentration for the first procedure. We are going to use the data for the first procedure, which is matter the volume of titration or volume used. The formula is, we are going to use the molar ratio formula. So molarity of W2 is equal to molarity of W1, volume W1 times the number of mole of W2 over volume of W2 times the number of mole of W1. To understand this, let's check clarification. W2 is molarity is acid, W1 is base sodium hydroxide, and that is the volume. Number of mole of acid is 1, number of mole of base, that is 2 mole.
So we are going to use this data to solve molality of W2, and in order to get the concentration. The question, we proceed with the same question to calculate the initial concentration of W2 acid in water. MW2 is equal to 0.1 sodium hydroxide times 25 of volume times 1 mole times 25 times the 2 mole number of base, number of mole of base. Because the data was, it means volume of W1 with sodium hydroxide after titration was 25 and the volume of pipette was 25. That's looks like the cell. The answer is 0.05 mole per decimeter cube. That is the molality. So in order to get the concentration, we have to make concentration molality times the molar mass. Molar mass of succinic acid is 118 gram per mole. So when you multiply, you get the initial concentration in water of W2 in water is equal to 5.9 gram per decimeter cube. That is the answer for the first question. The second question, final concentration. Calculate the final concentration of W2 in aqueous layer. That is the concentration by using the data in procedure B. That is, we find the final after succinic acid distributed or mixed with the aqueous or organic layer, organic solvent. The formula is the same, but the difference is data. You see the change of here, there is 22. There is 22 of this. There is 22 of this one. After titration, the volume of base of sodium hydroxide changed to 22, from 25 to 22, because there is a reduction. There is the concentration of sodium of succinic acid. There is changes by decreasing the concentration. So that's why the volume of sodium hydroxide is going to be high. That is our data. Our solutions, we get 0.01 times 22 times 1 mole divided by 50, or 25 times 2. The answer will be is equal to 0.0, not 0.05, is 0.044. That is an error for this one. This is not correct. The answer is this one. The concentration of W2 in aqueous layer is equal to 0.04 of succinic acid. In order to get the concentration, we take 0.04 times the molar mass 118. The concentration is equal to 5.192. 192. That is a concentration in aqueous layer. Another question, deduce or calculate the concentration of W2 in organic layer. We have in water, we have in aqueous, now we are going to find the inorganic. So in order to get the inorganic, the concentration of W2 or succinic acid in the organic layer, we have to make subtraction from the initial minus final. Because initial is high concentrated, final is lower concentrated, we have to make a subtraction, and the value would be the concentration of W2 in organic layer. Do you understand? So the formula like that. So The concentration initial was 5.9. The final was 5.192. So you see there is a changes. So after subtraction, the value is equal to 0.70. So the concentration of W2 in organic layer is equal to 0.708 gram per decimeter cube. That is the concentration in organic layer. So you take the initial minus final, you get the organic. Another question, calculate KD partition coefficient between water aqueous layer and the diethyl ether. So the formula is that when the partition between the first word would be up of the division between denominator and the numerator and the denominator. So aqueous layer would be upper side, and the diethyl ether organic layer would be down. So aqueous would be numerator and the organic would be denominator. That is the formula. When you look at the data, that is in aqueous layer was 5.192, but after minus you get the organic layer 0.708 gram per decimeter cube. The value is 7.33 because the unity have been cancelled. That is a partition coefficient between organic, aqueous and the organic layer. And that is a general experiment, or experiment number 1. Distribution coefficient between water and diethyl ether is 7.3. There is a range, can get it from 5 up to 8. That is a range of our KD, or distribution constant. That is our experiment number 1 in our topic partition. Experiment number 1. We are going to proceed with experiment number 2 if God bless us. So still be together with me to understand more. We have physics, chemistry and biology. I think you have enjoyed this lesson. Subscribe our channel, put a like and a comment there down on the description bar, but share to others in order to be in a wide to get the members to understand this lesson. My name is Mr. Magul, expert in physics, chemistry, biology practicals. If you want to help, you can communicate with me. There is my contact there through my description. You can call it, and then you can communicate, can help you, can assist you. If you are the school, you are private candidate, we can share through physics, chemistry and biology. I think that is enough. Thank you for watching. Don't forget to subscribe. Another day we'll be together.